Hello everybody. Today what we're going to be doing is talking about polar coordinates. Before we get started with that, I just want to kind of set the stage a little bit because this is going to be, it's going to take something that you already know, it's going to flip it on its head and make it something that is almost completely unfamiliar to you, which is kind of a cool thing but also kind of daunting at the same time. So let's talk about something that's familiar to you first. You've been using the coordinate plane for a very long time. You know, for instance, that this point can be called x comma y, and that the horizontal distance is the x coordinate, and the vertical distance is called the y coordinate. Points like this are called rectangular coordinates, or when we express points like this, they're called rectangular coordinates. Because if you were to like put them on this system of x's and y's, they sort of make a rectangle like that. So those are called rectangular coordinates. What we're going to be doing today is talking about a new way to talk about the points in a flat plane like this. And this new way is called polar coordinates. So polar coordinates take the same point, but instead of thinking about things as x and y, polar coordinates express that same point as the distance that point is from the origin, called r, and then the angle that that point is from the positive x-axis, called theta. So points expressed this way are called polar coordinates. Let's take a look at some definitions and how we would graph those. And please, at any time throughout this lesson, if you feel like I'm going a little bit slowly and you'd like to zip around and like maybe speed past some parts if you feel like you're understanding it, go ahead and do so, or move on to the practice or something like that, and refer back to this video if you feel like you need it. The goal here over the next few days is for you to learn and get comfortable with polar coordinates, and that might happen for different people at different speeds. Okay, to start off with, the polar coordinate system is a system for labeling points according to their radius, which we usually call r, and their angle, which we usually call theta. And then each point is written in a coordinate pair like this, r comma theta, instead of x and y. So you might see something written like 3 comma 65 degrees, or you might see something written as 5 comma pi over 4 radians. Those are all examples of polar coordinates. Okay, let's talk about some different definitions or some different little tweaks that you might see to polar coordinates as you graph these. So some big things. When r is positive, you travel forward along the angle theta. And when r is negative, you travel backward. Or in reverse along the angle theta. And then as we know from before, when theta is positive, you go up from the positive x-axis. Remember that angles like this are positive thetas. And when theta is negative, you go down from the positive x-axis. In this way. So this would be a negative theta. Okay, let's actually get to graphing some polar points. Okay, so polar points aren't too difficult to graph. You just need to get used to seeing these coordinate points in a new way. Instead of x comma y, you need to see them as distances and angles. And before we get started, let's do a little review of the unit circle and radian measures. So you guys know that this angle way out here at the start, hopefully you remember that that is an angle that's either 0 radians or also 2 pi radians. That means that this angle over here is pi radians. That means that this angle up here is half of that, or pi over 2 radians. And that means that this angle here is half of pi over 2, or pi over 4 radians, which is 45 degrees. And we can label in some other things too. For example, this line right here is pi over 6. And this line right here is 2 pi over 6, or pi over 3. And remember that when we practiced our unit circle, we also tried to get good at labeling particular angles. For example, this one might be 5 pi over 6 because we know that it's 1 pi over 6 less than 6 pi over 6, for example. So it's good to be familiar with those before we start graphing these. So for example, if I were to count around the unit circle here in pi over 6s, I might go 1 pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7, 8, 9 pi over 6, 10, 11, and 12 pi over 6, or 2 pi. And you'll also see some angles here that are given in both degrees and also some that are in radians. So you're automatically more familiar with degrees, so let's start with those. So let's graph point P right here. So 5 comma 60 degrees. What we're going to do is find the 60-degree angle mark on here. 60 degrees is right along this line right there. That's the 60-degree angle. And then in order to plot the point 5 comma 60 degrees, we move from the origin out 5 units. So let's count it. So 1, 2, 3, 4, 5. So 5 comma 60 degrees would be right there. So I'm going to put a point right there, and I'm going to label it P. And just to keep things clean, I'm going to excuse me. Sorry, I was just looking for the eraser to erase the line on that. Keep things clean. Okay, so let's take a look at the next one. Let's take a look at point Q right here. So 5 comma negative 60. First off, why don't you try to graph it? And then once you are done trying it, we'll come back and we'll check together. Okay, so first I'm going to go down to negative 60 degrees, which would be along this line. And I'm going to go out 5 units. So I'm going to count it 1, 2, 3, 4, 5. So this would be point Q. That is 5 comma negative 60 degrees. Simply because I'm out 5 units away from the origin, and this angle is negative 60 degrees. Okay. Next, let's graph negative 5 comma 60 degrees. Now this one is a weird one. It's something that confuses lots of people. So what I'm going to do here is I'm going to draw the 60-degree angle first. So just like we talked about before, this is 60 degrees. Now, we know that point P right here is 5 out. 4 would be right there. 3, 2, 1. That means that 0 would be right at the origin. That also means that my negative r's would be back here. So if I wanted to count out -5 for r, I would start at 0, and I would move backward along the angle line this way. So if I were to count this out, I would start here, and I would go 0, -1, -2, -3, -4, -5. So this point is -5, 60 degrees. Not because these numbers are negative. These numbers are labeled there just to help you be labeled the radiuses of the circle. But that is a negative radius because I started at 60 degrees, and instead of going this way, I went this way. So the opposite way of the angle, backwards, is a negative radius. Okay, why don't you try on your own this one, -5, -60 degrees. I'll erase a little bit and then meet you back up in a second. Okay, so if I remember correctly, -60 degrees is down here, down from the x-axis. And then instead of going forward along -60 degrees, I want to go backwards. So there is 1, 2, 3, 4, 5. Okay, so this would be my point V. -5, -60 degrees. So negative radiuses are opposite the angle that you initially find. All right, why don't you take a minute or two and try to plot all of these other points right here. And then after a little bit, I will come back in and we'll check where they are. Okay, so point A is 150 degrees, which would be about there. So there's 150 degrees. And then the radius is 3, so 1, 2, 3. So there's 3, 150 degrees. That's point A. Point B is -3, -150. So let's go -150. Be right about there. So there's the -150 line, and then I'm going to go backwards. So -1, -2, -3. Be right about there. So there's point B. That's -3, -150 degrees. Next, the radian measure ones. 2, pi/4. I know where pi/4 is. Pi/4 is if I go right up to the middle there, there's pi/4. And then 2, if I start from the origin, I'd go 1, 2. There's 2, pi/4. So that is point C. And then point D, -6, -5/6. So -5/6, I would start here, and I would count back. 1, 2, 3, 4, -5/6. So here's -5/6. So this angle is -5/6. And then to count backwards, I would count backwards a whole 6 units. So let's count back from 0. -1, -2, -3, -4, -5, -6. Way out here. Okay, so this point is -6, -5/6. Now, at this point, you might be noticing that, yeah, that point is -6, -5/6, but it might be easier to write that point instead as 6, pi/6, because it's in that same spot. And that's one of the key features of polar coordinates, is that you can actually have alternate labels with them. Instead of like just an x and just a y coordinate, you can have multiple different r's or multiple different thetas that you could choose based on where your point is. So let's practice that. Okay, so here, what we're going to do is we're going to plot the point given, plot the point P, and we're going to find two other polar representations of that point. So first what I want you to do is just quiz yourself real quick, plot both of these points. I'm going to plot point P in red, and I'm going to plot point P, the other point P, excuse me, in blue. Why don't you try that right now? Okay, so my first point P, which I'm going to call P1, would be at 45 degrees, and it would be out 2 units, so right about there. So here's P1. I'm going to erase the other stuff there. Okay, here's P1. And then P2 in blue is at pi over 3 and 5. So pi over 3 would be all the way out here. So this angle's pi over 3. And 5 pi over 3 would be out 5 circles. 1, 2, 3, 4, 5. Okay, here is P2 in blue. Okay, now let's find two alternate representations for each point. Let's start with P1. So in P1, you can see that my angle here is 45 degrees and the radius is 2. One of the first things that I can do to get an alternate representation is I can add 360 degrees or 2 pi radians to my angle to get a coterminal angle. And in this case, that alternate representation would be 2, comma, and then 405 degrees. Because if you go around 405 degrees from the start and go out 2, you end up at the same spot. So there's 360 and then another 45, and then out 2 I would get to P1 again. So that's an alternate representation. Another way to do this would be to use the negatives to your advantage. So what I might do here is instead of going up to positive 45 degrees, I might walk it back to this angle right here. And that angle would be negative 135 degrees. But then if I'm using negative 135 degrees, I don't want to go forward along this angle because that would put me in the wrong quadrant. To get back to point P1 and be at the same place, I would want to go backwards instead. So I would record that as negative 2, comma negative 135. And this would be using a negative radius to get an alternate representation. Let's do these for point P2. So in point P2, the first thing I could do to get an alternate representation would be to add 2 pi to pi over 3. So go around the circle one more time. Remember that 2 pi is the same as 6 pi over 3, because there's 6 pi over 3's in the whole 2 pi circle. So that angle would be 7 pi over 3, and I'd still be at 5. The other way to do this would be to go, okay, so that angle's pi over 3. What if I were to start from this angle instead? So I might choose to say that this angle right here is, let's see, negative 1 pi over 3, negative 2 pi over 3. And then I wouldn't want to go forward along that angle because my P2 is in the first quadrant right here. So I want to go backwards from negative 2 pi over 3. So I would say negative 5. Also keep in mind that you don't need to do that with negative angles. You would be perfectly okay using another coterminal angle for pi over 3, or not coterminal, but another angle that would represent this same one right here, which would be 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So you could say this is 4 pi over 3, and then still go back along the negative radius that way. So this alternate representation we just added 2 pi to our angle. And then in these two, we used a negative radius. This skill is pretty brain-bendy for finding alternate polar coordinates. You need to be comfortable with both angles on the unit circle and also comfortable locating what quadrant you're in and what quadrant you need to be in. And that takes a little bit of time to get comfortable with and a little bit of practice too. What I would actually recommend that you do from here is take that practice worksheet that you've got and try plotting some polar coordinates and also try writing some alternate representations of them as well. And then check yourself against the key that's posted on Classroom just to see where you're at for right now. There's still a little bit left that we have for polar coordinates. So this first part is just getting, whoops, moved everything, is just getting familiar with polar coordinates. That's what our goal was the last few minutes. And then the next part here, we will be converting polar coordinates. So why don't you just take some time to get familiar with these polar coordinates right now, and then you can check back in with the other things after that. Okay, so at this next stage, what we'll be doing is we'll be converting from polar coordinates to a rectangular system of coordinates, and also in the other direction as well. So I need you to underline or box 4 things before we get started. Those 4 things are this relationship right here, and also its equivalent, that. I also need you to underline or box this one, and this one. Oops, and I forgot one more. Here we go, this one. So all of these relationships, they might actually look familiar from vectors, because that's kind of where they come from. You might think of this equation right here as the magnitude of a vector. You might think of this one as the horizontal component and the vertical component. Maybe you remember like magnitude form and component form and stuff like that. That's basically where this is coming from. If you have a point that you have written as x comma y, you can think of that point as a triangle with x and y, and it's a right triangle too. So all these right triangle trigonometric equations apply just from thinking about that. And these are what we're going to use to convert from rectangular to polar, and also from polar to rectangular. These ones down here are the easiest, but these ones are a little bit tough, primarily because you need to think about the quadrant that you are in. Okay, so let's try this out. Okay, so for this first point right here, the first thing you'd want to do is calculate what the radius would be. And the radius, just like we pull from up here, as you can see, the radius is given as the square root of x squared plus y squared. So this radius would be the square root of 3 squared plus 3 squared. So that would be the square root of 18. And then to find the angle, theta, what we're going to do is use this equation, this formula right there, the one for tangent. And we're going to just use it in one quick jump as inverse tangent is going to give us our angle theta. We're going to do the inverse tangent of y over x, which is the inverse tangent of 3 over 3. And if you do that, you would end up with 45 degrees, or pi over 4 radians. You can use either one. It might be more comfortable to use degrees for right now. So this point could be written as the square root of 18, comma, 45 degrees. Okay, let's try the next one. The radius would be the square root of negative 2 squared plus 8 squared. And that would be 4 plus 64, so this would be the square root of 68. And then the theta would be the inverse tangent of 8 over negative 2. I'm going to grab a calculator and do that real quick. And from that, I get negative 78.96 degrees. Now, there's a problem with this, though. This particular angle is in quadrant 4. Negative 78 is in quadrant 4. However, negative 2 comma 8, if you were to graph that, that's in quadrant 2. So in order to get around that, we're going to do the same thing that we did with vectors, and we're going to actually add 180 degrees to that angle, and that would give us a polar point of the square root of 68, comma, 104.03 degrees. All right, let's do the next one. 0 comma negative 2. Let's start by finding the radius. That'd be the square root of 0 squared plus negative 2 squared. And you might be aware that 0 comma negative 2 is just, well, right here. It's you're not moving left to right at all, and you're going down to 0, negative 2. So it should make sense then that the radius is the square root of 4, which is just 2. If you were to do inverse tangent, however, you would get negative 2 over 0, which would give you an error or undefined. However, you can get around this by going, oh, even though that doesn't work, I know that the angle that's made by 0 comma negative 2, I could call that negative 90 degrees, or I could call that 270 degrees if you prefer to go the other way. So this polar point could be written as 2 comma negative 90 degrees. Okay, why don't you try this last one here, and then I'll put in my work and you can check your work against that. Okay, so the radius is the square root of negative 4 square roots of 3 squared plus 4 squared. So this would end up being the square root of 48 plus 16, which is the square root of 64, which is 8. And then my angle theta I can find by looking at the inverse tangent of 4 over negative 4 square roots of 3. And that gives me negative 30 degrees, which again, this is a quadrant 4 angle, and if you made any mistake with this, I would bet it might be this. This is quadrant 4. This point, however, is in quadrant 2, so we do need to add 180 to the negative 30 degrees, and that gives us a polar point of 8 comma 150 degrees. Okay, so there's our last polar point. So converting from rectangular to polar is kind of annoying, primarily because you need to think about the quadrant in which you need to put your point in. However, going from polar to rectangular is a whole heck of a lot easier. So let me show you how. You want to make sure that you have your calculator in the right mode. If you're given an angle in radians, you want to be in radian mode. If you're given an angle in degrees, you want to be in degree mode. But in order to convert these, really, all you have to do is apply these two formulas up here, which really we know from our study of vectors and magnitude form. So here's how it works. What we're going to do is say the x-coordinate is the radius times cosine of our angle, which in this case is pi, and the y-coordinate is the radius times sine of our angle, which in this case is pi. Now for the x-coordinate then, what we end up with is positive 2, and the y-coordinate we end up with 0. So this rectangular coordinate is 2 comma 0. Boom, there we go. For this next one, you'll want to be in degree mode. The x-coordinate would be 3 times cosine of 135 degrees. And the y-coordinate would be 3 times sine of 135 degrees. And let's see what we get from that. So this would be negative 2.121. And then 3 times sine of 135 would be 2.121. So our point would be negative 2.121 and positive 2.121. Okay, why don't you try the other two and then you can check against my solutions. Okay, so going from polar here to rectangular, I got positive 2.5 for the x, and for the y-coordinate, I got 4.33 for my y. Again, that's just doing negative 5 times cosine of 240 degrees. That was my x. And then for the y, I did negative 5 times sine of 240 degrees. And then for this last point here, I'm going to use my knowledge of the unit circle. You might have done it in radian mode on your calculator with decimal numbers, but either way is okay. For my x-coordinate, I know that 4 times cosine of pi over 6 would be 4 times the square root of 3 over 2, because cosine of pi over 6 is the square root of 3 over 2. And then 4 times sine of pi over 6 is 4 times 1/2. So this would end up simplifying down into 2 times the square root of 3 and 2, because both of these fractions simplify into these numbers. Okay, that's pretty much it. If there were, what I want you to do now is go ahead and try some of the problems in the practice sheet if you haven't already. Pay special attention to just being able to graph the polar coordinates. Remember that you're looking for an angle and a radius out from that angle. So r comma theta. Remember what it means to go out to an angle and then go backwards to a negative radius as well. And then just practice finding alternate representations of polar coordinates too. That was what we did in the second part of the lesson here a few minutes ago. So practice those and just try to get comfortable with polar coordinates over the next few days as much as you can, and then check Delta Math for that assignment as well. If you have any assignments, please feel free to email me. I will be checking my email all week and making sure that I stay on top of answering questions as much as I possibly can. All right, thanks guys, bye.